Please open this Excel sheet, which I have opened, the day 2 data frame.
Yes, sir.
Okay. So this data has come from a meta-analysis. This one, it has come from this meta-analysis. So what we wanted to see was uh, dental care service utilization among adult Indian population. So the data has been curated between 2011 and 2022, and around ultimately after screening and everything, we could identify around 21 studies. Okay. So here outcome was proportional. So what was the outcome? The outcome was this. Just a minute. Uh, so outcome was basically in last 1 year. If you so it was a yes no question. In last 1 year, if you had visited a dentist's office or a dental care facility or not. So if they tells yes we have visited, then we will count it as a positive response, and we will count that as a proportion. So simply based on that, the N in the F column, it is the sample size of the studies. In the E column, it is the event rate, that is your estimate. So out of 575 people, they told 48 told that they have visited in the last 1 year or 6 months. So
Yes, sir.
then similarly for the next study, out of 600, it is 216. So this is then on the D column, it is the study zone. So these are administrative zones of India: South Zone, West Zone, Northeast, and Central, and East. Column C tells you about the gender. So some studies have involved both male and female, so that's why we have coded as both. And there are some studies which have only included females, so we coded those as female. And column B is based on years. So some studies will be within 2017 to 2022, and some studies would be within 2011 to 2016. So some are most recent and some are older studies. So clear till now regarding the data set?
Yes, sir.
Okay, so for RStudio, or I have another file, I have shared one zip file you must have seen, which is called Meta Essential, right?
Yes, sir.
So have you guys downloaded and extracted that? Have you seen what is it?
Yes, sir.
Okay, so
Yes.
Meta Essential is essentially a Excel workbook which has been developed by Erasmus University. So this is a wonderful package, Excel-based package, where you can do the complete meta-analysis. This is the most easiest method of doing meta-analysis, and so I will show you both. First, I will show the meta-analysis through Meta Essential, and then I will show you through RStudio. And Meta Essential is validated, so any journal accepts that. Even there are journals like Lancet have accepted studies which has done on Meta Essential, so that won't be a problem. And it actually prepares some beautiful plots also, so I will show you that. And have you guys heard of Meta Essential or have used earlier?
No, sir. No, sir.
Anyone else?
No.
Okay, sure. No issues. Anyway, so both for Meta Essential and for RStudio, one strenuous step we not strenuous, one little step we need to do is we need to create the data frame. So you see, I have kept this column names as P standard error, UP means confidence interval, upper confidence interval, and LO means lower confidence interval. So we need to calculate these columns. So simply, and please start doing while I am doing. So you have your laptop, right?
Yes, sir. Sir.
Okay. So P is simply the proportion. So we will just divide column E divides by column
F.
N. Then standard error. What did I say? The formula of standard error if we are dealing with proportion?
Square root.
Square root. Square root of square root of P into 1 minus P divided by your sample size, that is N.
1 minus.
P into 1 minus T
Yes, sir.
divided by sample size.
Sample size.
The,
F2.
yeah, F2. The whole thing would be under square root, okay? Okay, so then what is the formula for confidence interval? P plus then
1.
P plus 1.96, that is the Z value based on the table, into, sorry, 1.96 multiplied by the standard error. Okay. So upper confidence interval is P plus, that is your point estimate, any kind of estimate it can be, plus 1.96 into standard error. Similarly, for lower confidence interval, it would be.
No. Sir, sorry to interrupt. Can you please repeat that standard error again?
Yeah, sure. So standard error, when we are dealing with proportions or any kind of prevalence data, the formula for standard error is square root
Of
P
P minus minus 1 minus P. P whole into.
P into 1 minus P divided by sample size. P is your proportion. So under a square, P multiplied by in bracket 1 minus P divided by sample size. Look, the formula is here in the, what is it called? I don't. Can you see the formula?
Yes, sir.
Yes, sir.
So are you guys done? Someone was having some problem. Have you fixed it?
Yes, sir.
Okay. So similarly for lower confidence interval, what would be the formula? Same. We'll start with P, but here it would be minus 1.96 multiplied by standard error. Okay. Everyone completed up to this?
Yes, sir.
Okay. So now just select all these four.
Oh, sir. Sir, 1 minute.
Yeah,
Uh,
yeah.
Sir, after standard error column,
Mhm.
then uh,
After standard error column, there is UP, that is upper confidence interval. You can write CI also, UCI also. Just write whatever you feel.
okay. Formula, sir.
Formula for confidence interval is what? It is
P,
if you have.
P, P plus 1.96 into standard error.
Yeah.
P plus 1.
1.96 into standard error.
Yes. Then LO.
LO means lower confidence interval. You can write LCI also, or whatever you think, whatever your wish.
It's formula, sir. Sorry.
Arey, so upper was plus, so lower would be what? P minus. Same thing, just instead of plus, you have to put minus. P minus 1.96 into standard error. See the formula here in above.
Yes, sir.
Okay, done?
Yes, sir. Thank you.
Okay, so now you have to select all these four rows and at this end there is one small square. When if you just put your cursor over that, a plus sign will come. Just double click there.
Yes, sir.
Done.
Done, sir.
Or you can just drag also. Same. So everyone done, right?
Yes, sir.
Yes, sir.
Okay. So just save this worksheet. Now open another worksheet which is called Day 2 Meta Essential Test Data. Have you opened?
Yes,
Yes,
sir.
sir.
Okay, so now tell me, so this is like a very intuitive workbook. I already told it is developed by some PhD students. It was their PhD thesis in Erasmus University. I'll show you the work actually, just a minute. Okay, so this is the website for Meta Essential. It was done by Robert Sarmond. Robert Sarmond and Tony Hack. So they were Robert Sarmond was PhD student under Tony Hack. So as a part of his PhD thesis, he built it. So this is validated, and you can use this package. And the zip file I have provided you guys, it contains every kind of worksheet. Like if you just open that Meta Essential 1.5 file, so here every kind of outcome data, you will get 7 workbooks. So the first workbook is Meta Essential Effect Size. It is a generic workbook which we would be using today because proportional data meta-analysis can be done here. Second one is Meta Essentials when the outcome is difference between independent groups. So suppose uh, for RCTs, you want to see vaccine effectiveness between two new vaccines or two old vaccine or old or new whatever. So the two independent groups are there. So in that case, you would be using the number 2 file. Number 3 would be for continuous data. So if like two new drug has come which are working on blood pressure. So the blood pressure is a continuous data. You will be using number 3 file. Number 4 is, I guess, just a minute. Number 4 is dependent group continuous data. That means uh, same group. So first they have been given a particular drug, and suppose maybe in follow-ups or some pre-post study is there. So post intervention they are again measured. So it is the same group and continuous outcome is there. Then you will be using the fourth one. If it is a correlational data meta-analysis, so you want to pull data regarding correlation of two variables, then you would be using the fifth one. And seventh and sixth one is not that much required right now, so you can actually constrict in the first 5. Today I'll be showing you the first one, and showing others is not actually in the scope also. It's very vast, but you can go ahead and play with these things. These are very useful, and you have a user manual also, so they actually have depicted how to do and everything. So just you can try it out. Anyway, let's come back to that day 2 meta essential test data. So now tell me, just now we created a data frame, right? So just tell me in column D, which will be coming, which data will be coming. Column D is effect size. So which data should we put here from our previous data frame?
G.
Yeah, perfect. So just copy that column and paste it there, and paste it, don't directly paste it, okay? Paste it as numbers, like right click on it, then paste options will come. So paste as numbers. Done. हो गया.
Yes, sir.
Others, everyone completed. Similarly, put
Yeah.
other columns also. For standard error, just copy paste the standard error column and paste it as numbers. Again, I am saying don't paste directly. So what will happen now? If you paste like this directly, the formulas will be gone. It will draw in formulas from your previous from the worksheet where you have copied actually. So we don't want that. So don't paste it directly. Just right click and paste as numbers. Then which one should we paste in place of column F? Which data we should paste on place of column F? Column F is number of observations. So which data should come here? Anyone?
Don't know, sir.
Huh?
Don't know, sir.
Hey, number of observations means what? Just translate it into your own language. Number of observations mean what? Sample size.
Sample size. Okay.
So sample size is n.
N.
So just copy it. Again, paste it as numbers. See, once you paste all these information, automatically this data sufficiency check will be done. So if I just undo the changes, see, if we just undo the changes, now data sufficiency is showing as no. So you do not have sufficient data. So it has these internal checks. So, and secondly, these study numbers are also not done on column A. So once you paste all the data,
Mm.
just a minute. See, once you paste the number of observation, that is the overall sample size, which is actually required to calculate other data also. The study data sufficiency will automatically check to yes. See, the next column is checked as no. On 23rd row, it is checked as no, but up to 21. And the numbering is also there in column A. Okay, so now coming to subgroup. Now, one problem in this is at a time you can check with one subgroup only. In case of other softwares, multiple subgroups can be checked at once. But here you have to use like this workbook, you save with one subgroup and copy this workbook, and you have in that workbook you can check with another subgroup. That is not a problem. Ultimately, you have to produce different forest plots and different analysis. So it won't be a problem. Anyway, so for now, So which one should I use? Which subgroup should I use? Tell. Subgroups are which one in this data frame? In this data frame, which columns are subgroups?
So is it study zone,
Yeah, obviously study zone and
gender?
and D
Yeah.
also. B, C, D all are subgroups. Anyway, we will do it suppose study zone now. Okay. So just copy that study zone column D and paste here again as numbers. Gender generally we do not keep as subgroup. Gender generally kept as moderator. Anyway, so all are done, right? Up to this.
Yes, sir.
Okay, everyone completed?
Yes, sir.
Yes, sir.
Okay, so now go to this data. एकदम top में एकदम ऊपर में that toggles will be there. File, home, insert, page layout, formulas, data. So click on data and
Okay.
then click refresh all.
Refresh all.
This one.
Yes, sir.
Okay. Okay. So you are done. Completed. Your analysis is already done. So now just go to another sheet, forest plot sheet. Have you gone? Come to the forest plot sheet.
Yes, sir.
So see on cell 2, cell A2, that is column A row 2, there are mentions of model. Here A2, cell A2, column A, row 2. Model is mentioned.
Yes, sir.
After that, it's written random effects model.
Yes, sir.
You can change here. See one drop down box has occurred. So whichever model you want to use, you can change here. If you want to use fixed effect, it would be changed like that. If you want to use random effect, it would be changed like that. So for now, we'll be keeping the random effect model. Okay.
Okay.
Similarly, below there is presentation. So presentation sort by, this is just telling you the order of sorting. So these are just making the forest plot visually appealing. So sort by entry number means those numbers 1, 2, 3, 4, 5, 6. So it has sorted the outcome based on the entry numbers. But you can also sort by study name, sort by effect size, or whatever you want. So suppose we want to sort it by study names, we can change that. And then order ascending or descending. Ascending, descending would be fruitful if you are sorting by effect size or standard error or weight, etc. So which are meaningful. Like if we want to sort by effect size, then we may want to see ascending order or descending order. See, our forest plot is changing on the right side. So it is now ascending. So just click descending order. See, it has changed. Anyway, for now, we will just click as sort by study name. Okay, so clear?
Yes, sir.
Okay, so now come to the combined effect size. Here is your pooled effect size, which is coming as how much? 0.24. Sorry. So what is 0.24? That means 24%. So the people who are using dental care in the last 1 year, in overall India is 24%. Now let's just go back to our study and see what was our result there. Sorry. See, our result was 23.96%. So it's the same. This is because of rounding off the minor इधर उधर जो हुआ है वो that is because of the rounding of these effect sizes or using the z value as 1.96 because it is not exactly 1.96. There are some 9.95 something something something. So if you can exactly use that particular number, it will come like that. But it's not a problem. It's perfectly fine. So your combined random effect pooled proportion or pooled effect size is the result of your meta-analysis is 24%. Then your lower confidence limit is given as 16%. Upper confidence limit is given as 31%. So the whole thing would be people using dental care in India in last 1 year is 24% with the confidence interval of 16 to 31%. Clear? Clear?
Yes, sir.
Everyone up to this clear?
Yes, sir.
Okay, so now come to the heterogeneity column. Look at the Q value. What did I say? Any Q value more than the number of studies you have included would be heterogeneous. That means Q value, if it is equals to or less than the number of study samples you have included, then you can say it is not heterogeneous. But if it is not the case, if the Q value is much more, then you can safely say there is much heterogeneity. So here Q value is around 1900. So obviously heterogeneity is there. Then your I square, that is I square statistics, which is coming around 98%. So it is highly heterogeneous study. Because why? Because see, these studies are done in community-based setup. So different population, different kinds of there are recall biases, then different methodology would have been used. So many things are there. Clear till this? Everyone clear till this?
Yes, sir.
Okay. So now come to the weight portion. Someone was asking that, ki how weight is designated. See, for each study in column I, there will be weight assigned to each particular studies. So suppose for the first study, Burman et al., the weight is given as around 4.77%. Now, if you actually go back, okay, let's identify which study has got the highest weight. So quickly tell me which study is the one which has got the highest weight.
4.94.
Okay, so which study is that?
Gupta 2015.
Okay, so let's go back to our input and we'll see what was the sample size of Gupta 2015.
5,476.
So see, so this was a considerably large study. So it has been assigned much larger weight. Not much larger, but at least larger than the other studies. And similarly, which one has got the lowest weight assigned? I guess it is 4.65%, right?
3.48%.
How much? Oh, acha, 3.48. Okay. So Kahar et al. Kahar 2016. So go to input again and check what was the sample size. Yeah, it has got just 35 sample size. So sample size is so low, we cannot completely um, give trust on this study. So obviously it will be assigned much lesser weight, right?
That depend on sample size.
not exactly just on sample size. There are many factors there. What did I say? While weight is what? Weight is inverse of the variance. Now, variance is what? Variance is standard error square, right? So standard error formula was what? Here it is root over p into 1 minus p by n. So AC square is p into p 1 minus p by n. So n is in the denominator. Um, so ultimately, if you take its inverse, so ultimately this n will be above in the numerator. So obviously, when weight is assigned, as the sample size is more, the weight would be more.
Okay, sir.
Clear? So not just the sample size, it depends on the sampling strategy, how it has been selected, then what is the precision of the study, how the sample size has been calculated, what assumption has been taken in calculation of the sample size. So all of those actually depicts how this weight is assigned. And the formula is simple, that is 1 by variance. Clear?
Okay, sir.
In the K column, you see weights are shown as part of percentage. Same thing here in I column, it is shown as percentage, and in K column, it is visually depicted. Now come to your forest plot in the L column. Can you see the forest plot?
Yes, sir.
So which one is the pooled effect size here? What did I say? Forest plot is number one. There would be individual studies with their confidence interval, and there will be one diamond. Here, diamond is not there. The representation is different. So the green one is the pooled effect size. In Meta Essential, they plot it like this. You can change if you want. You can change. You just have to click here, and this right side button thing will come format data point, and then you can, I guess, change it. Okay, so I don't know how to change it. I will have to see. There definitely would be options for changing it, but it's not currently here. I'll have to see. You can also just, it's Excel, simple Excel, right? So you can also see how to change this icons. That is possible. But now one thing is how to just copy this forest plot as a publication worthy plot. So just click here in any of the blank spaces inside this effect size border. Just click, then copy it, go to your Word and just paste it. See here your forest plot has come. Now you want some other data also, right? Just this won't be sufficient. You want the name of the studies. You want the weightage of each study that has been assigned. So here you have to do something little more. You just insert a table. Okay, so first make the layout as landscape. Then insert a table. Insert 3 columns in a table. And on the third column, you paste that forest plot copied from Meta Essential. Now in the second column, you paste the weightage, this one. So just copy that weightage column K. One thing you need to you need to do also. I'll just show. If you copy directly, this will come something like this. So you cannot do that. So you have to change the axis format, axis option. See here, there are more than 27 up to 2004 numbers are there because Meta Essential currently supports up to 200 studies, I guess. So they by default put all those in here. So what you need to do is you click on the vertical axis here. This 1, 2, 3, 4, 5, 6, all it is written now. You click on this vertical axis, right click, format axis. And click on this maximum category under horizontal axis crosses. Or still it won't change or what? I think it still won't change. Just a minute. Just a minute. Okay, I don't even know how to change this. So it's better just copy from column I. Copy your weights from column I and just paste it in your Word document. And you have to do a little work post analysis. So what you have to make is here you have to create tables. So there are 21 studies. So you have to make 21 tables in here, 21 subtables in here. So something like this. Split cell. Number of columns are 1, but you need rows around 22, I guess. So then under each study, so from one studies are starting, so under each study you have to put all those weightages. And similarly in this column also, corresponding to each weight you have to put the study names. Is that clear? A software gives you the whole thing in a single plot, but in Meta Essential this is a problem. You won't get like that. So forest plot you will be getting like this, but after that you need to craft the other details by yourself in Word file or in an Excel, wherever feasible. Is it clear?
Okay.
Okay, so next see. So next comes our subgroup analysis. Acha, one thing, just remember, whenever you copy the forest plot also, just right click on the axis, this vertical axis on column L. So which is saying 1, 2, 3, 4, 5, 6, all the study numbers are written. So just right click and ensure that everything is set as auto, like horizontal axis cross, automatic, axis options, bound. Bound you can change actually, like here the bound is given as -2. If suppose we keep this as 0, the problem would be the effect size will be blurred with the write up effect size will be blurred. So to make it clear, this we have to change. So better if we keep like -5. So it will be much clear. So it will have some space in between. So it's better to keep it as -2 or -3 something. And maximum, how to denote what is maximum? Anyone? What should we keep as maximum?
Number of studies.
Exactly, ekdam. But not the number of studies. You should add at least 2 or 3 more lines along with that. Like we had 21 studies, so we had kept 23. This is because um, 0 will start from this effect size bar, and 1 will be very close to that. And the last one, 22, would be the overall effect estimate. So one extra for the overall effect estimate and another one extra for some space. That's all. We can keep 22 also, but that would be so clumsy, I guess. So it's better to keep it as 23. And suppose you have subgroups, then you should, if you have 2 subgroups, you should take +2. So 23 +2. If you have 3 subgroups, like in that um, geographic region, WHO geographic region, there are 4 regions, right? So you should keep as 23 plus 4, if something like that is there. Anyway, so up to this, tell everyone it's clear now. You literally can do a meta-analysis from prevalence data, right? Any problem? You're facing any problem, you can tell me up to this, because after this we'll go to subgroup analysis, then other things. Any explanation, anything you want to know? अरे बोल दो सब कोई हाँ या ना.
It's fine, sir. आप
Okay.
कुछ चीजें नहीं समझे, but we'll get you to.
Okay. आप बता सकते हो वैसे. Anyway, we'll come to the subgroup analysis. See, the subgroup analysis same here in the column B, C, D. There will be the effects. The whichever effect you want to choose, you can choose here. Like you can toggle between fixed effect and random effect. And then if you come to the combined effect size, the combined effect size will come somewhere around column H. See, the central zone has got a proportion of around 18%. Column H, row 5, H5, central zone has got a pooled estimate of 18%. East zone, just one study was there, so it is as it is 21%. North zone, there are, I guess, 1, 2, 3, 4, 5, 6, around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, around 11 or 12 studies. So North zone estimate has come around 11%. Similarly, South zone has got 30%. The most utilization was from third zone. So these are subgrouped effect sizes, and you can get the confidence interval, lower and upper confidence interval. See, it is written here as CILL. So confidence interval lower limit and confidence interval upper limit. Similarly, see here within each subgroup they have assigned weightage. So each weightage is 100%. So for these three study, if you calculate these three with 18% plus 39% plus 41%, it would be around 100%. And so from 100%, the weightage has been given to each study. See, Kahar had got the least amount of sample size. So that is why the least amount of weight has been assigned to it, 18% around, 19% around. Basu et al. Has 39% and Khoisnam et al. Has around 41% weightage. So similar for other subgroups too. So let's come to the subgroup effect forest plot. So here you can see uh, each studies are represented as these circular blue dots. So these circular blue circles are the each individual effect size, and the overall effect size has been depicted with these lines, these red and black lines. We have some kind of number error in this. Just a minute. Anyway, I will have to see later. Anyway, this is the way you should do, and tell you another example. I'll show you another example. This some kind of error is there in the numbers. This is divide by zero error. That means in place of the inputs, there is some kind of error is there. So we have to check that later. Anyway, it will take much time. So let's not concentrate on this error. If suppose this kind of error is coming, what you should do is in the input section, you should round off these big numbers. Like here, the number is 0.834 and all everything. So what you should do is in the Excel sheet, in your data frame, so in your data frame, so these big numbers are coming, no? So just behind that, you should put round off. Like in standard error, before this, you should put round off. Either you can round up or round down. It's always better to round up. And then close the argument. If you are watch it. Round up to two numbers. So like this. So you should round up. Then this kind of error can be avoided. Round up, you should do up to 2. If you want, you can take up to 3 also. So like this, you can change the how many fractions should be there behind your point estimate, behind your fractional points. Anyway, anyway, so similarly, from the effect size from this one, from this forest plot, if you want to copy this, what you have to do is again, you go to format axis. Here the maximum is set at 210. So there are come around 210 studies. So that is not required. So you should put 27 here. So we have got around 4 subgroups. So just 27. So it will change, and then just copy it and paste. After pasting, you need to just drag it to normal shape. So it's like this. Drag it to a visually appealing shape. The same thing do for the effect size also. There we have to start from, it is starting from 0. So that's why it has kind of came overlapped. Either you can just remove it like this, or you can change there, whatever is feasible for you. Is it clear?
Yes, sir.
Okay. Okay, so now we will go to moderator analysis. I actually don't have any moderator here. So what we can do is in in the moderator analysis, you just put what can I put? Moderator can be okay. Let's put urban and rural. Okay. So first some 10 study I'll put as urban, and rest other study I'll put rural. Then whenever you put new data, you always go to data and refresh. So you go to the moderator analysis sheet. Here it is kept as fixed effect, so we need to change that, which we should change that to random effects. And again, while same problem, some kind of data error has happened. Error in value. Which value? So the problem we were doing is we cannot keep categorical variable as text data. It has to be numbered. So the same problem was happening before also. We kept as south zone, north zone, all those things. You need to code that data. So the string should be in numbers, not in text. Is that clear? That you need to remember. Like in moderator also, instead of writing urban rural, you need to code it as 1 and 2 or whatever, like some kind of numbers. Then it will come. Text data it won't recognize. Okay.
Yes, sir.
Okay, so what is moderator effect? See, moderator effect means the name suggests, right? Moderator, is it moderating the overall effect or not? Can we say there are disparity among dental care utilization between urban and rural region or not. So that is what moderator tells you. So how should you interpret the moderator effect? Number one, you go to the intercept. Intercept, you go to the beta coefficient. Here the beta coefficient is 0.22. Okay. So then you need to see the p-value. So beta for the intercept, p-value is significant. If it is significant, go to the residual. So residual is around 34%. So the more the residual, the more the moderator analysis is not working in your favor. 34% residual is much. Then you come to R square. I was telling yesterday that in meta regression, R square means how much how much can it explain the heterogeneity. So see, it is only 0.15%. So just when under 100, just 0.15%, just 0.15 portion heterogeneity is explained by this urban rural because we just created that variable, right? So obviously it's a fake made up variable. So it is not at all explaining the uh, effect of dental care utilization, the variance of dental care utilization in different regions. So anyway, it was just an example. So if you have a moderator, you can put it here. So generally, moderators are income classifications or maybe gender also, male, female. We have a gender here also, but that is a gender variable also. But that is some studies are female and some studies are both. So anyway, this is what. So next come to the publication bias analysis. See, this is important. Again, on the A and B column, it is given fixed effect. You tell us now. You tell me what we need to look at. What changes I need to do here. Anyone? Just look through the sheet right now and tell me the changes I should do.
Lower limit minus
Sorry,
में
I couldn't hear you. Please tell again.
सर लोअर लिमिट माइनस में है
लोअर लिमिट माइनस में है कहाँ?
ऑब्जर्व ग्राफ के नीचे
Okay, lower limit. No, that's not. That's prediction interval. See, it is PI lower limit, PI lower limit, PI upper limit. So that is prediction interval. This also must not go negative. But see, these are Excel-based calculations. So if it is negative, you have to report it as 0 because these are just numbers. Whatever number that Excel has got, he has supplied you that. So this one thing is very important. This can come in normal CI also. In some cases, you will see that some CI will come as minus 0.14 or some upper limit will go more than 100. That must not be the case. So if you are seeing such kind of thing, so just report. If it is more than 100, report within 100, just report 100. And if it is minus, just report 0. These are not mathematically wrong. The calculation is perfectly right because Excel don't do any kind of galti. But the thing is, it doesn't make sense. So it has predicted it can go negative, but dental utilization of negative क्या होगा? कुछ नहीं हो सकता. So that is why these are just logical flaws. That's all. But anyway, this is a nice point. But one major thing we need to change. Nobody told यार this is fixed effect किया हुआ है तो यहाँ पे random effect करना है.
Yes, sir.
The moment you do random effect, see the plot and everything will change a little. Automatically it will do that. See the effect size has come 0.24. Q value is around 2400. CI lower limit is 16, upper limit is 31, same. Then one important thing. Okay, just a minute. Okay, so from this plot, tell me in the
One
screen.
question.
Yeah, tell.
Sir, why we need to मतलब कि क्यों हमें ये पब्लिकेशन बायस एनालिसिस चाहिए?
अच्छा, क्यों चाहिए? ठीक है। तो मान लो जैसे काहिर एट ऑल का स्टडी था, उसका सैंपल साइज कितना था? 35 था अराउंड,
35,
राइट?
ओके, हाँ, यस
बहुत
सर।
कम था। तो अब मुझे सपोज डॉक्टर रेड्डीज लेबोरेटरी ने पैसा खिलाया उनका पेस्ट बेचने के लिए, ज्यादा करके सपोज गवर्नमेंट ने एक इनिशिएटिव लिया है फ्लोरिडेटेड पेस्ट के लिए। तो अभी टेंडर दिया हुआ है और रेड्डी को टेंडर मिला है, बट गवर्नमेंट इज कॉन्टेम्पलेटिंग ऑन वेदर टेकिंग द फ्लोरिडेटेड पेस्ट फ्रॉम रेड्डी और नॉट। अब रेड्डी क्या करेगा? तो रेड्डी दिखाना चाहेगा कि हाँ, सपोज दैट दिस प्रोग्राम इज गोइंग इन ओडिशा इन सम विलेज। तो रेड्डी क्या किया वहाँ पे? स्टडी वगैरह किया करके, बहुत छोटा सा एक स्टडी किया। पता चला कि ये कहेरिटॉल स्टडी जो है 35 सैंपल साइज में स्टडी करके रिजल्ट पब्लिश कर दिया कि डेंटल केयर यूटिलाइजेशन यहाँ पे है 70%। तो वी मस्ट डू दैट डू मस्ट रोल आउट दिस प्रोग्राम ऑन दिस पर्टिकुलर एरिया एंड वी हैव आवर प्रोडक्ट रेडी। तो ये सब बायस प्रॉब्लमेटिक होता है। तो दिस वुड बी
To
बायस्ड
minimize
सिलेक्शन।
the biasness of the study.
मिनिमाइज द स्मॉल स्टडी इफेक्ट, बिकॉज स्मॉलर स्टडी से जो रिजल्ट आएगा दोज आर नॉट दैट ट्रस्ट वर्दी, राइट? क्योंकि ना तो वहाँ पे कंफाउंडर एडजस्टेड है, ना वहाँ पे तुम्हारा बहुत सारा पैरामीटर्स को टेकन केयर किया गया है। तो द लेस द मोर स्मॉल द स्टडी इज, द मोर इट इज नॉट ट्रस्ट वर्दी इफ द आउटकम इज वेरी कॉमन। लाइक कोई एक रेयर डिजीज तुम ढूंढने जाओ, तब छोटा स्टडी हो तो चलेगा। बट अब तुम एनीमिया का एस्टिमेट करने जाओगे, 10 लोगों का एनीमिया लेके तुम स्टडी कर दिया, या 30 लोगों से एनीमिया एस्टिमेट लेके तुमने स्टडी कर दिया, तो दैट स्टडी वोंट बी दैट मच ट्रस्ट वर्दी। सो टू अवॉइड द स्मॉल स्टडी इफेक्ट वी नीड टू एसेस द पब्लिकेशन बायस। फिर कभी कभी क्या होता है, बहुत सारा स्टडीज होता है जो पब्लिश नहीं होता है, ग्रे लिटरेचर होता है, राइट? तो क्या करते हैं बहुत लोग कि वो सब स्टडी मेटा एनालिसिस में इंक्लूड ही नहीं करते, बट देयर रिजल्ट्स मे बी इम्पोर्टेंट। स्मॉल हुआ बट मे बी सपोज, नहीं स्मॉल नहीं, मान लो स्टडी अच्छा है बट नॉन सिग्निफिकेंट रिजल्ट आया उनका। तो मेरा हाइपोथेसिस अगर ये रहेगा कि मुझे सिग्निफिकेंट रिजल्ट चाहिए, तो आई वुड ऑलवेज ट्राई टू नॉट इंक्लूड दो स्टडीज। तो ये स्मॉल स्टडी इफेक्ट, सिलेक्शन बायस, ये हटाने के लिए हम लोग पब्लिकेशन बायस चेक करते हैं कि स्टडी सिलेक्ट करने में हम लोग कोई बायस तो नहीं हो गए थे। तो इसका देखो, जब तुम एक्स एक्सिस देखोगे, तो एक्स एक्सिस ऑफ द पब्लिकेशन बायस इज ऑलवेज इफेक्ट एस्टिमेट, इफेक्ट साइज। एंड द वाई एक्सिस अगर देखोगे तो सम काइंड ऑफ प्रिसिशन, जैसे यहाँ पे स्टैंडर्ड एरर दिया हुआ है, राइट? तो जब तुम स्टैंडर्ड एरर और प्रिसिशन मान लो, प्रिसिशन वर्सेस इफेक्ट साइज प्लॉट करोगे, तो क्या होगा? तो जो स्टडीज जिसका इफेक्ट साइज छोटा है बट स्टैंडर्ड एरर बहुत कम है, तो तुम्हारा इस क्वाड्रेंट में, बट मतलब लेफ्ट लोअर क्वाड्रेंट में आना चाहिए वो सब स्टडीज। सिमिलरली देयर शुड बी सम स्टडीज जिसका इफेक्ट साइज बड़ा है बट स्टैंडर्ड एरर भी बहुत ज्यादा है, तो that should come where? That should also come in this region, right lower quadrant। तो हमें देखना है कि सारा चारों जो क्वाड्रेंट है, इसमें स्टडी रिप्रेजेंटेशन सही से है या नहीं। मतलब did we include all the studies available there or we just cherry picked the data? जैसे मान लो हम लोग चेरी पिक कब करेंगे? हम लोग चेरी पिक करना चाहेंगे कि ज्यादा इफेक्ट साइज हो, स्टैंडर्ड एरर कम हो। इसलिए देखो यहाँ पे ज्यादातर स्टडी इस अपर लेफ्ट क्वाड्रेंट में ज्यादातर है। देखो स्टैंडर्ड एरर जितना कम है और इफेक्ट साइज भी मोटा मोटी है, तो ज्यादातर स्टडी आर सेग्रीगेटेड ऑन दिस अपर लेफ्ट एंड सम स्टडीज ऑन दिस अपर राइट क्वाड्रेंट। इज दैट क्लियर? So to avoid this cherry picking, we need to see the publication bias. Are we clear? Is it clear? Hello?
Sir, so which studies to be excluded now? I mean, the ones at a higher distance from X as well as Y axis.
No,
I
no,
mean,
no,
that kind of.
not that. Publication bias does not tell you whether to exclude or include your study. This is after you have done your analysis for you or for the readers to see whether you have cherry picked the data or not. What I'm saying, suppose you are biased towards the conclusion. So what you will try to do is you try to choose studies which has got greater effect size. That means in this bar, how I can मार्कर वगैरह नहीं रहता है क्या यहाँ पे जूम पे anyway in this column from column H to L this effect size bar is there na from -20 it is going to 1.20 so we will try to look for studies which will come into this area so more effect size but lesser precision sorry more effect size but lesser standard error right
Mm, right.
so, so that is like the best studies standard error भी कम है precision भी ज्यादा है तो ये पब्लिकेशन ब्लास्ट प्लॉट में वो दिख जाता है कि ज्यादातर स्टडी यहीं पे कंसंट्रेटेड है बाकी जगह पूरा खाली है तो यू कैन से कि हाँ यहाँ पे पब्लिकेशन बायस होने का एक चांसेस है एंड देन यू कैन एक्चुअली गो अबाउट इट टू सी अगेन एंड देयर आर सम टेस्ट्स आल्सो दैट यू कैन कंडक्ट जैसे मान लो ये वाला पब्लिकेशन प्लॉट सो मेन थिंग तो एक तो तुम देख सकते हो आप देख सकते हो कि एसिमेट्री कि फ्रॉम दिस मेन इफेक्ट बोथ साइड ऑफ द मेन इफेक्ट सिमेट्रिकल है या नहीं विजुअली जब देख रहे हो इफ द प्लॉट इज सिमेट्रिकल then you can say okay publication bias may not be there if it is asymmetrical then तुम बोल सकते हो आप बोल सकते हो कि यहाँ पे publication bias रहने का chances है जैसे in this particular plot it is asymmetrical more studies are concentrated in clusters in particular place जैसे ज्यादातर study यहाँ पे low standard error and मोटा मोटी एवरेज इफेक्ट साइज में कंसंट्रेटेड है तो ये इसके अनुसार मतलब पूरा इंडिया में इस प्लॉट के अनुसार पूरा इंडिया में ऐसा स्टडी हुआ ही नहीं जिसमें स्टैंडर्ड एरर ज्यादा है सारा स्टडी एकदम बहुत अच्छा है इस प्लॉट के अनुसार सो देयर इज ऑब्वियसली पब्लिकेशन बायस क्लियर नाउ okay so how to know this publication bias in terms of test there are some tests that is called Eggers test that we use to know if there are existence of publication bias or not तो एगर टेस्ट का रिजल्ट यहीं पे कहीं पे होगा हाँ हियर इट इज so see here it is written one is Eggers regression test and another is Beggs-Majumdar rank correlation test so you need to see in Eggers test the p-value if it is less than 0.05 if the p-value is significant then only you can say there is existence of publication bias here as per this Eggers test it is saying there is no publication bias but as per Biggs Majumdar's rank correlation test it is showing there is publication bias 0.04 so it is significant so you have to actually report all these three tests and the visual plot also so first point is by seeing the visual plot there is asymmetry or not if there is asymmetry there is publication bias like this particular plot here second is the Eggers test if Eggers test p-value is less than 0.05 there is existence of publication bias if not no publication bias and then the Biggs-Majumdar test if the p-value is less than 0.05 again there may be existence of publication bias now if you have if you have actually seen कि publication bias is there, then what you can do, क्योंकि पब्लिकेशन बायस वाला एस्टिमेट तो ऑब्वियसली बायस्ड एस्टिमेट बोला जाएगा कि हाँ तुम तो सारा स्टडी इंक्लूड ही नहीं किए होंगे, और मे बी देयर मे बी सम अदर स्टडीज, और देयर इज अ नीड फॉर अदर स्टडीज, or more robust studies are needed which are quality controlled properly. So one thing is there which is called trim and fill analysis. So what is this trim and fill analysis? Just come down and see there is an option called trim and fill. Everybody can see that. You can see the trim and fill analysis.
Yes.
Okay, so just toggle it as on, make it on. And the second portion, keep it as leftmost run / rightmost run. Whatever it is, just keep it as it is. Then now see the plot. Can you appreciate some difference? What has it done? Can anyone tell what has it done in the plot?
Studies from Y, three studies have been,
Inputted, yes.
marked, no?
Yes, these three studies, which are these yellow circles, yellow unfilled circles, these are the three studies which it has inputted. So trim and fill, what is it essentially do is it kind of makes the forest funnel plot symmetrical. So its assumption is if we would have these three studies, and then what would have been the corrected effect size. So these three studies are hypothetical. So it has calculated the effect size of individual studies, and then it has inputted these three, and you will see a corrected effect size will occur. Come down, see here the column adjusted effect size. तो ये यही बोल रहा है कि अगर ये तीन स्टडी होता तो हमारा करेक्टेड इफेक्ट साइज वुड हैव बीन 0.19, जो हमारा था 23.96, नाउ इट इज करेक्टेड टू 19%, 24% था। अगर हम लोग ये पब्लिकेशन बायस है यहाँ पे, अगर पब्लिकेशन बायस नहीं रहता, ये तीन स्टडीज यहाँ पे रहता, these studies are hypothetical, then the corrected one would have been 19%. So this is what trim and fill do. But while reporting for any journal, you must not report the adjusted one. You should report both, because your final estimate would be the uncorrected one only. Then you need to see the confidence interval of the uncorrected effect size. See, it is 16 to 31%. Now you should look if the adjusted effect size is falling within the confidence interval of the uncorrected one or not. Like adjusted effect size was 19%, and the observed or corrected effect size, adjusted effect size is 19%, and your uncorrected confidence interval was 16 to 31. So 19 is in between 16 to 31. So pretty much you can say ki our estimate, your estimate, or whatever the analysis you have done, it is kind of okay, as the corrected estimate has not passed out of the confidence interval. So that you can say, but you should report everything. But your final result will be this only, uncorrected one only. If suppose it would have been 12%, then it would be a problem. Then you would have to say कि हाँ 12 तो obviously 16 से 31 के बीच में है ही नहीं, so then this is a problem. Then you would have to acknowledge the publication bias, and you would have to say more research is currently necessary, and instead of saying one particular estimate, you would have to say a range. So from like 12 to 24%, anywhere in between it can be. So this is what about forest plot. Though this much nobody does, I am very sure that there will be out of 10, just one or two publication would be there who have done trim and fill analysis or all these things. It is just there that that's why I'm saying you can do or you may not also. It won't be a problem because having publication bias is perfectly fine. You just need to acknowledge that and report all these tests. Number one, Akers test, p-value, and Biggs-Majumdar test p-value, and this plot. That's all. Okay, so any question till now? Could everyone complete the whole thing?
Yes, sir.
Okay, so any question, any problem, any doubt? अभी कर पाओगे ना आप लोग, क्योंकि देखो ये तो अभी प्रिटी इजी है, आपको सिर्फ इनपुट ही करना है, बाकी ऑटोमेटिकली इट विल कम. तो आर यू कॉन्फिडेंट कि हाँ फ्रॉम दिस यू कैन डू प्रिवेलेंस मेटा एनालिसिस?
Yes, sir. But practice is needed somehow. So
Obviously.
we'll practice and get you again. Yes, sir.
Okay.
I mean, some terms we are not, we could not catch them, but I think
अच्छा.
we'll see video again and maybe, or we'll get back to you, sir.
Okay, sure. बाकी लोग? Okay, I'll just call up names, otherwise nobody will talk. Atul Jena. Krishna sir is also there. Krishna sir.
Ronik,
हाँ sir.
actually, see, around 6:30 I joined.
हाँ.
So good. But what I thought, no, in
हाँ.
Meta Essential,
Hmm.
the figure are will be not as much as clarity like R and Stata, no?
No. Obviously, sir. Our
Hmm.
data is class apart. This is like,
Hmm.
but nowadays journals are accepting this also, and as this is pretty
Hmm.
easy, so both I thought I would show. R is
Hmm.
also there in next.
Hmm.
We'll
Again,
just.
what I thought, I
Hmm.
think in R and that Stata,
Hmm.
so most probably the software will be do most of the things.
Yes, exactly, sir.
Here they will be, at least if they understand what is this utility more
हाँ,
practically, then they can use it. And
exactly,
yeah.
sir.
And I can tell you, everyone
Hmm.
also, that the data extraction is more important. How
वही
you
sir.
extract the data, then here everything, that the Excel sheet is very important. Then automatically everything will be calculated, then you can interpret it.
वही sir.
But if I ask 2, 3 question to any one of you, so for a prevalence things, what are the key parameter we need from the data set? Key value or key variable we need from the data set for a prevalence calculation.
Okay, so from the participants, anyone?
Maybe Deepa, what do you think? Suppose when you are extracting the data, so you want to do it's a prevalence study, you want to do a meta-analysis of this prevalence study. So what are the key value you will search from the paper studies?
You can start from whatever you had in your data frame today, then regarding what else you will need.
Deepa,
The
is it
number of cases.
very important? Yeah, the total number of sample is very important first.
Yes, sir.
Total sample, then total cases.
Yes, sir.
That means what is the prevalence exactly in number, not in percentage. If it is given in percentage also, you have to convert it into the number. 600 out of 600, how many are the dental cases? So that is very important. Second is that another important point. If you want to do okay, it is overall prevalence in the studies. If you want to do some subgroup analysis, then you find out which subgroup it is, urban, rural, or whatever it is, among under 5 children or 1 year children. So that subgroup wise data you have to search. Here subgroup, south zone wise, here south is given. And
Yes, sir.
so that is very important when data extractions. You know that sometimes some of the
Gender specific, sir.
yes, male, female, if you want, male,
Yeah.
female, both, rural or urban. It depends on the research question, what type of subgroup analysis you want to do. So that is very, very important for data extraction. So if you extract the data, then yes, I know that you will be not do standalone the meta-analysis. So anyone of us could help you do this. Usually, I never use. I had Meta Essential, but I never use Meta Essential. But I use Stata. So it is easy. But the only thing is Stata is a no paid software.
हाँ सर वही but
But
फिर
but Stata has also certain limitation in the sense you cannot do. Last week I have discussion with Ronik also for the costing data you cannot do in Stata.
हाँ
They
वही
are
वो आर
also.
में ही होगा सर.
R only provide that again. Then, but Stata has some for like Ronik in Meta Essential we can do for also sensitivity, specificity data, diagnostic accuracy.
No sir, they have
They
not yet
they
have that.
they only develop for the prevalence and a
No.
randomized control trial. Okay,
हाँ
these are
हाँ
the
so
things.
these are the 6 7 they have right now. So you have independent data, pre-post,
Okay.
dependent also, correlation also, partial and semi-partial correlation also. So these 7 workbook right now they have.
Mainly first three are very important.
Yes.
Yeah. So like either relative risk odds ratio you can see or mean difference, or you can see the prevalence. Mostly in the you can do prevalence, but those who are doing RCT then they have to go for the other model. But I think very good that from this meta essential it is very easy to understand the whole steps.
वही सर that is the best thing कि
हाँ.
हाँ इसके बाद वो है ये कैलकुलेशन भी
But
यहाँ पे
but
पूरा
if
दिखा
you
देते
if you share this Excel sheet, running just in
हैं. हाँ.
WhatsApp group, I can show them in Stata. You just
हम्म.
take me one line, then it will
अच्छा.
be give automatically this figure and that
हाँ वो
thing.
तो अभी सर वही हम लोग आर भी करेंगे अभी
हाँ.
तो आर में
So
वो लोग
then I have another question also. So how because you know that these all are also some of them are very non-statistical background.
हम्म.
So for them, mm,
हम्म.
I think basic R which is necessary for meta-analysis or that
हाँ
we should. If will be they will be in the
वही हाँ.
beginning class onwards they will be very afraid of with R. Then that will be very difficult.
हाँ सर वही आर एक्चुअली मतलब सिर्फ मेटा एनालिसिस के लिए यूज करने के लिए आर दे कैन एक्चुअली अंडरस्टैंड.
Learn, no? So
हाँ वही.
then R Studio it
हम्म.
will be easy for them.
आर स्टूडियो would be easy for them. Just R would be difficult because that has
Then I think we can focus on R Studio and
हाँ
in R Studio also meta-analysis is possible, no? Then they will be easy for
हाँ हाँ
them
सर
too.
आर्ट स्टूडियो में तो सारा ही मतलब सब कुछ ही हो.
Hmm. So I think so next week probably, no? We will start.
नेक्स्ट वीक में आज ही सर आज ही और मतलब we'll go beyond the time because मेरा तो आज ही लास्ट डे है.
नहीं नहीं ना ऐसे कुछ नहीं है लास्ट डे रोनी.
अच्छा सर ओके.
So I thought Abhinav actually I was I discussed with Abhinav tell Ronik to have some basic classes on the R also before
ओके.
meta-analysis in the R. So have 1 2 classes basic classes on R. So we may extend this session. Then I think Frederick classes we can have last 2 classes, which will be more useful for all of us also.
ओके हाँ
Then we'll see that. But yeah, maybe we can have last week some gap. Then let them to studies and at least get some data. Then they can do hands-on. So
हाँ वो
that
तो
is very important that I am thinking.
फॉर
So
फॉर नाउ सर जैसे मतलब कोई भी अगर प्रिवेलेंस मेटा एनालिसिस इनमें से करना चाहेंगे तो दे कैन जॉली वेल यूज दिस मेटा एसेंशियल एंड इवन आजकल जर्नल्स भी ये एक्सेप्ट करता है, बट हाँ ऑब्वियसली यहाँ पे बहुत कुछ होता भी नहीं है,
हम्म।
जैसे
नहीं
देर आर
नहीं
मेनी प्रॉब्लम्स।
नहीं, I think most of the thing they are addressing
हाँ
in
वही,
the publication bias, adjustment, many things they are
इवन
addressing and it will be.
इवन सर आप देखो,
हम्म
यहाँ पे ये गैल्ब्रेथ प्लॉट वगैरह सारा दिया हुआ,
हम्म।
तो नॉर्मल क्विंटाइल प्लॉट, गैल्ब्रेथ प्लॉट,
फ्री में तुमको कितना देगा?
वही।
So that is there. I think doing most of the thing. Second also Meta Excel,
हाँ मेटा एक्सेल इज आल्सो देयर।
but Meta Excel also again that is from only prevalence studies, no?
हाँ only prevalence, and meta excel is rather a little tricky to install also।
Yes, yes. Tricky to install. Again, that comma, full stop, lot of things
हाँ
is essential for that.
वही सर।
Yeah, that's good. Uh, so Ronik, usually you do sensitive diagnostic accuracy in R, no?
हाँ सर, इन आर्ट्स डायग्नोस्टिक एक्यूरेसी मैं अभी तक एक ही किया है, तो
Mm-hmm.
दैट वाज माय फर्स्ट लर्निंग आल्सो।
No, in Starta,
हाँ
there is
मैंने,
a recently they added 2022. So that very easy, nothing to do. It will be
अच्छा
give good plot also. Just you need true negative, true positive, true that value only. So based on that they give.
ओके।
But yeah, so I think that is good. So if they want to do this in the starter, I can show them also quickly.
हाँ ओके सर,
But I
बेटर,
need that Excel file.
आई विल सेंड द एक्सेल फाइल।
Just Excel file you send me. Just Excel file in. I can show them.
ओके, तो अभी भेज दो आपको।
हाँ अभी भेज दो, व्हाट्सएप में भेज दो अभी। So Melinda, very few participant.
Yes, sir. So this week there are very few.
They are afraid of statistics or what?
Uh, could be. Could be, but I think this is December weekends, no? So I think everybody is either at weddings or they're busy holidaying somewhere.
So रोनिक भेज दिया?
हाँ सर अभी भेजो। हाँ सर भेज दिया।
Just I'm downloading.
हाँ अभी क्या होगा देखिए।
हाँ आ गया। So
वैसे ये जैसे मैं आर के लिए प्रिपेयर किया था, तो
नहीं
ये
I
आर में
think
भी।
हाँ I think R में it is good also
हाँ
that means along with R Studio. Let me share my screen. Entire screen कर देते हैं. So my screen is visible, no?
हाँ इट्स कमिंग सर।
So just I have to start. So what I'll do, I just open my starter file. Then I just import the Excel, which Dr. Ronik share. So that then I Excel. So it is in my desktop. I'll import this. This is day 2. Then I will open it. Then I'll just import first row variable name. Then now it is imported. So then what I'll do here in the starter the command is meta probe. So I will start meta probe for proportion prop meta probe. Then I have to see this prevalence or proportion what is calculated, that some n number. So then I will put here n. Then here is your total number, hopefully the n. Then I will use a comma. Then I will be use that random effect model. No, that is here the command is ftt random. So if I use because fixed effect model you can use ftt random. Then I will be need also my label name var. Nahi? I have to label bracket then name var equal to my name var is
Study would be there. It would be study, sir. Capital S, rest small.
y study. Then I'll close it. What I'll do power.
Sir, screen is stuck, I guess.
I think Sir lost his internet connection or something.
Mostly, maybe. So if the participants are fine, then I can go for another half an hour to show them in RStudio, or you can arrange any other day. It's completely up to you.
I mean, yeah, we can do another day also, but a weekday would be better, I think, for everyone, if it's just half an hour.
For half an hour, weekdays, weekends or weekdays, you are saying?
Weekdays.
अच्छा weekdays, weekdays तो फिर सबसे best कोई भी दिन.
Yes, because next weekend we have the next session, so maybe Tuesday, Monday
Yeah,
or
sure.
Tuesday.
Mm-hmm. Monday works also, Tuesday works also, no problem.
Okay. What does all the participants, what do they think? Can you just let us know in the chat box?
Okay.
So see, Meta Essential is very easy. That's why I showed it to you guys, because data, every time you need to copy commands and do things. So Meta Essential is just you put the data and things
Connected.
automatically
I
will come.
disconnected.
Oh, hi, to Krishna sir
So
came.
so again just okay. So here Ronik, I think here the study power is here that study name is not mentioned probably, no?
Sir, study name is under the level study.
Acha, label, okay. So here
हाँ.
if you put the study name, then automatically the study comes. So if you want to do so simple I learn, then you see it will be shows also study. We study 1, 2, 3, but you can say study name also. If you are in that exactly Excel sheet, it's a study level is there, no?
Study level is there. Under
Mm,
the column study.
okay, under the column study,
Hmm.
but I put this under the study variable, it is not showing. Let us describe. Okay, study. Okay. Hmm.
So it has stored as strings, and I think you have to change.
Yeah, that's right. It is not. Okay, so let us use.
Hmm.
I think it is somehow. No, so STUDY study. But it will again, I'm showing this also. So that will be again, if I say here the by variable. So which variable that like subgroup analysis by, then the by study zone. Okay, study copy by study zone. No. By study zone. Study zone. Study zone is the same है ना?
हाँ सर सेम।
हम्म,
ये स्टेटस है आई गेस वो नहीं लेगा ना, कोडेड नहीं है ना सर, आर वो ले लेता है।
नहीं ये ले लेगा थोड़ा इसको ये करना मैं एग्जैक्टली वो डाटा को ये कर दिया ना
अच्छा
तो
अच्छा।
इसलिए so I think it's very simple way you can
हम्म।
do this by her one. So yeah, so the overall concept is that no, so you can do this whatever the software you can use this, but the concept is very important. But what I want to hear says that everything it will be calculated, but you need the sample size. You need the that proper total sample size like this n and capital then the total sample out of total sample this then if you want subgroup analysis then you say that okay the what is the subgroup analysis or that so then it automatically it will be calculated that one line command will give you the answer. So this is the thing. So here also it calculate the effect size and also automatically give the weight also given. Like the study you say 3.9 to someone is 4 point something highest one say 4.94 something it's given. So same principle it is given.
हाँ सर, आई
Okay.
फॉरगॉट टू मेंशन अनदर थिंग सर। जैसे in proportion whenever we are taking like in RStudio or Stata also, we should not take the raw proportion. We should transform the proportion either log based transformation, like if you are doing in Excel, simply you can write equals to log proportion, it will convert. Or you can in RStudio or in other software, it can be directly done also. It doesn't affect that much, but some journals, some reviewers I have seen, they reply as a comment ki why didn't you take transform proportion rather than you to raw proportion, because they said raw proportion is unstable. So that is also one thing you should remember.
So
Otherwise,
they are asking for raw one now, log one.
log 1 sir वो मांगता है.
That's why in the strata logistic in strata in the random for the odds and relative risks they gives this as a log.
हाँ सर वही.
So I think it's good. Ronik, you will be start today the R1.
I have asked, they are saying some other day, half an hour, maybe on Tuesday, most of them are saying. So I think Tuesday,
Maybe
Can do Tuesday after 7 p.m.
perfect for me. So
Okay. Okay, then I'll schedule a session. I'll let everybody know in the group and by email.
yeah, sure.
So thank you, Ronik.
Thank you, sir. Thanks a lot.
Thank you, sir.
I think only the learning will come once you start some studies, then
वही.
you extract your data, then you will apply it. That's all. Otherwise. So ठीक है, Melinda, you can continue. I'm leaving. So if you want continue, just continue. हाँ? हाँ.
नहीं अभी तो हो गया फिर हम
हाँ,
लोग
हाँ.
Tuesday will meet then.
Okay.
Okay.
Thank you everyone for joining in.
Thank you.
Today, this would mark the end of the session.
And just last, any question, anyone?
Thank you, ma'am.
Any doubts till now? Obviously, there would be doubt, but any burning doubts? Madhushmita, Deepa, Mahesh, Puri, Monajit, Shamal sir, anyone?
No, sir.
Okay, okay. So, well, the main thing you remember always in meta-analysis, it's the main thing is inclusion of the studies. If that is perfect, anybody will give you a meta-analysis or you can do. Today you saw the meta essential. You can easily do there. And RStudio also Tuesday I'll show. The part required for meta-analysis doesn't require that much coding or whatever. You will be given a script also. You can copy paste the script and you don't have to remember the script also. The main thing is what happens beyond the equations. Why is it important? Those things. And I think I have shared one book. Everybody has got that book, right?
Yes,
Yes,
sir.
So go by that book. That is an excellent book on meta-analysis. Whatever I have learned from that book only. It is by Higgins. Not Higgins, sorry. It is by Matthias Eger. I was saying na, that Eger's taste. So he is that Eger. And he's there in Twitter also. You can follow him. He keeps giving very nice materials also. Anyway, okay. We'll leave then for
thank you,
today.
sir.
And have that meta essential
Okay,
workbooks
sir.
with you.
Thank you.
And please keep on studying. Another thing I forgot. That heterogeneity you saw, na, it was very high heterogeneity. So do one thing in home, change the sample sizes and make them very close to each other. Then see how that heterogeneity is changing. You will see the heterogeneity drops. If the sample sizes are very close to each other, suppose 101, 102, 103, you will see heterogeneity is dropping. So the less the variance, the less the heterogeneity there will be. So these things you can change and you can see how the results is changing. So play with all those workbooks. And one thing, Melinda, are you there?
Yes, please.
I was saying, as a culmination of these sessions, can we have do we work on a publication like in next day, Tuesday? Can I choose one topic and in the meantime they will work and all 8 of them can be an author in that and we can by the end of all the sessions we can have that ready.
I think that they had I missed a few sessions in between. Dr. Deepa, Dr. Deepa,
Yes.
yes. So I think weren't you guys distributed into groups and
Yes,
assigned
we are.
topics? Yes.
My group is Madhushmita, Ananya, and me and Archana.
Okay.
And we
Yes.
have select
Yeah, what
also
was the
we
topic
selected.
again? Madhushmita, could you tell us what your topic was?
Okay, anyway, that's not a problem. I was
Yeah, so
thinking,
we had a few topics. I think they were working
yeah.
on cervical cancer and diagnostic tools, something like that.
Yes.
Yes.
Yeah, then fine, no issues. I was just thinking
Advanced technologies in cervical cancer.
okay,
Mm-hmm.
no issues.
Yes.
Then fine, no problem. Anyway, okay, we'll leave.
No, I think if
Uh,
you are interested, what we can do is assign mentors. We do assign mentors to the group. And so far, I mean, we have mentors, but I think somebody who's a meta-analysis expert, you know, you can just work with any of the topics you are interested in and you can help them out.
we can do that actually. I was thinking like
Yes.
here now around 8 people are there, so
Yes.
they all of them can work on a topic, and as I'll choose some very interesting but yet short topic which will have not many studies to start with. So
Sir, we will
can
share our topic.
sure.
We
No
can, we have prepared also sort strategy and all.
Acha, okay, nice.
And we also do inclusion and exclusion criteria for the
Okay. Okay, the next day we'll see then. No issues.
yes, sir.
Okay. Thank you so
Okay.
much. Thank you so much.
Okay. Thank you. Bye. And keep working on those workbooks. Just change the numbers, see how is it changing. Anyway, bye.